Let's ask ourselves a pretty straightforward question. What is a vertex? There are a lot of different definitions, but we're going to focus on specifically vertexes of curves. And for our sakes, we're mainly going to be focusing on the vertexes of a parabola that's formed by, for example, a quadratic function. So let's start thinking about what we know about parabolas. Here we have two different examples. One example where the value of a is greater than 0, and one example where a is less than 0. Now we know from our previous studies that an a greater than 0 gives you a parabola that opens upwards and has a minimum value, and an a less than 0 gives you a parabola that opens downward and has a maximum value. Now, from our talk on symmetry, you'll remember that the line that runs right through the dead center is that axis of symmetry that's been labeled already, and that's the line that you could fold one half of the parabola over onto the other, and they would match up perfectly. Talking about our minimums and our maximums, remember those are the values that are either the lowest point the graph ever touches or the highest point that the graph ever touches. And you'll notice, if you look at this, that the way it's marked out is that our vertex is the point that's found where those two values meet. That is, that a vertex occurs wherever the axis of symmetry and the minimum or maximum for the parabola intersect. The thing is, there are several ways to define what a vertex is, so let's look at one or two. So imagine for a second that you have a coordinate plane, and on that coordinate plane is a graph. Now, instead of a parabola, we're just going to say that it's a series of straight lines in a V shape. This would be some sort of an absolute value function. Now, as we look at this, we could say, well, we have two lines that meet, and if we want to figure out what its vertex is, we could start by looking for an axis of symmetry and then find where the minimum or maximum was and discover that our vertex is right there. And that would work as well. So that works for any pair of lines or curve. Now another way to think about it is to think about slope. I've redrawn our little graph so we can sort of think about slope. In very generic terms, the slope of this portion of the line, that is everything to the left or negative side of the origin, it has a negative slope value or negative m value. And that's because if you look at our rise over run, you'll see that we have a negative rise and a positive run. If you look on the right side of our vertex or axis of symmetry, you'll notice that we have a positive m value. That is, we have an increase in our rise, we have a positive rise and a positive run. So again, on the left side we have a negative divided by a positive for our slope, and on the right side we have a positive divided by a positive. So we get a negative slope or a positive slope. The vertex occurs right here in the middle, where we move from having a negative slope to a positive slope. Wherever we change from one slope to the other is going to be a vertex. As we look at this, this seems kind of complicated. And what happens when you have, for example, a curvy line? In this case, you have multiple changes in slope. You go from positive to negative, meaning there's a vertex here. You go from negative to positive, meaning there's another vertex here. And then again from positive to negative, and you have another vertex here. So that's not always the best indicator of where your vertices are. Let's look back at one of the parabolas we've looked at before. If we look at this, what we really want to think about is the easiest way for us to determine where the vertex is. And on a parabola, that's to look for those two initial values. Number one, where is our axis of symmetry? What is the line that runs directly through the center of the parabola? The other line we care about is where is our minimum? And in the end, where those two lines meet up is going to be exactly where our vertex is. So, for our purposes, our vertex is the point where the axis of symmetry and the minimum or maximum of a graph intersect. So it's wherever those two touch. Right now, we're still finding our vertices, our axes of symmetries, and our minimums or maximums by examining the graph itself. But pretty soon we'll move on to mathematical ways to determine where these points are.